First of all, I look at this function. I realize it's type, what type? Let me write it here. F of x equals x minus 1 divided by x minus 1 times x plus 4. What type is it? Type 2. Very good. So for type 2, I already know something. Once you say type 2, then I know what? Very good. Right. Both ends, the end behavior or the horizontal asymptote must be 0. Very good. Excellent. Good. Perfect. Now, of course, I need to start with a domain. What is the domain of this function? Very good. So -4, 0, 1, absolutely. However, before I conclude anything, I have to go back, and I realize now that after I stated the restrictions, I can simplify this function into this, which makes it very clear that the function has 1 or 2 vertical asymptotes. 1. Which one is it?
X minus 4.
Exactly. X equals -4 is a vertical asymptote. What is x equals 1?
It's a hole.
Yes. It's a hole in the graph. Absolutely. Very good. I want the x-intercepts. When y is 0, correct? But a fraction is 0 only when
X.
a fraction is 0 only when
The numerator is 0.
can the numerator be 0? So there are no x-intercepts. Now, what about when x is 0, which is the y-intercept? 1/4. Now, I need left and right. I know here there are infinities. Here they will not, because this is a hole in the graph. Left and right here will not have infinities. So let's plug in 1 in this function and tell me what you get on the left. 1/5. Plug in 1 and tell me what you get. We're not talking about signs here, right? Because this is not infinity. So plug in 1. What do you get? Perfect. Okay, now I have to determine the signs here with -4.1 and -3.9. Please plug in -4.1 here and tell me just the sign. Please plug in -3.9 here and tell me just the sign. Good. Can this function be symmetric with a hole and 1 and a vertical asymptote at -4? Can it be symmetric? No, but I have to write it because I need to show that I know that I have to study symmetry. So f of -x I will write does not equal what? Which would have been an even function. And it definitely does not equal -f of x, which would have meant an odd function, symmetric with respect to the origin. Very good. So I will say not symmetric. And now I can go back and graph the function. I would like not to do this on here because I don't want to go back in time. So when I graph a function with asymptotes, what do I have to graph first?
Yes.
Correct. And they're not part of the graph, but they have to be graphed. So they're not solid lines. So this is x equals -4. The other one that is already there, this is an overkill. There is no need to do this. It's the same line, will be y equals 0. Now I look at my chart and I try to make sense of the information I have. Let's see if we can. On the left-hand side of the first asymptote, it's coming from approaching 0. This is not 0. It's approaching 0. As x approaches -infinity, y approaches 0. From approaching 0 down to -infinity on the left-hand side of the asymptote. That's clear. No questions there. Remember, the function cannot cross the x-axis. There are no x-intercepts. Okay, So then, on the other side, I have 0, 1/4. I'm going to say that this is the point 0, 1/4. And I have at 1, 1/5, which is a tiny, tiny number. So allow me to do that. So I'm looking what happens here. From approaching infinity, it will cross the y-axis at 0, 1/4, will continue to decrease from 1/4, which is 0.25, to 0.2, right? At 1, where it has a hole, both sides approach 1/5, and there is a hole, and then approaching 0. So this must be it. Does not go away from the asymptote, it continues approaching it. So this is our function f of x, x minus 1 over x minus 1 times x plus 4. Can anyone give us the range of this function? Say it again. The range. So the domain is clear. Between negative infinity and negative 4, union negative 4, 1, union 1, infinity. So let's write it. I think it's a good idea. So domain, negative infinity, negative 4, union negative 4, 1, union 1, infinity. But I'm asking about the range now.
So negative infinity to 0, 0.
Yes, negative infinity to 0, union.
0, 0 to 1.
It's 1/5. That's the y value. We're talking about the y values now, right? So union 0, comma 1/5, union, exactly. So imagine now that you are crossing this graph with horizontal lines. Yes, 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 no. Yes, 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 no at 1/5, and then yes, 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 all the way. So there are two gaps in the graph, at 0 and at 1/5. Good. Anything else? Other questions here? Other questions? Yes, Chris, anything for me? Anyone? Yes, which one?
Number 83.
Yes, 83 on
And what was
section, page, anything.
section 3.2.
Read that to 83. Section 3.2. 80. 82. 83. The volume of a box. We did something similar in chapter 2. An open box is to be constructed from a piece of cardboard 20 by 40. So I have 20 by 40 in centimeters. By cutting squares of side length x from each corner. So imagine this. I don't need it. Imagine that this is a square. It's not. Oh no, it's not a square. I'm sorry. It's 20 by 40. So I have 20 here and 40 here. And imagine that I do this, and I remove a square from here, and a square from here. Has to be the same size. Obviously, in my example, it's not, right? So they have to be the same side. And I'm going to fold the sides and make a box. Right? Bear with me. I know it's not a box. It's not going to hold anything. But that's how we do it, right? Okay. So this side is x. This side is x. This side is x. This side is x. Right? Okay. So then, once I fold it up, I get something like this. So what will be the length, what will be the width, and what will be the height? Notice that I haven't even finished reading the problem. So it says an open box is to be constructed from a piece of cardboard 20 by 40 by cutting squares of side length x from each corner and folding up the sides, as shown in the figure. Express the volume V of the box as a function of x. So what is the length? So this was the length. Now what is the length?
40 minus
So this is 40. Now I'm interested in this. Now this is the length of the box.
40 minus 2x.
Very good. So what is the width?
20 minus 2x.
What is the height? Exactly. So what will be the volume? What is the formula for the volume of this box?
40 minus 2. Well, same time with
Yes. So 40 minus 2x, 20 minus 2x, and multiply by x. Of course, I'll multiply these and then multiply by x. So what do I get? So give me the function, please. Anyone has the function?
4x cubed.
We have it? Multiply by x and everything?
Yeah,
Okay, I'm ready.
4x cubed
Yes, it is positive. Very good.
minus 120x squared plus 800x.
800?
Yeah.
Okay, good. So part B. What is the volume? What is the domain of V? Use the fact that length and volume must be positive, of course. So what is the domain? Look at the way we built V. So this is part A, and in part B we want the domain of this function. Obviously, it cannot be a negative number because we're talking about x, and x is the height, right? So what x can be maximum, which is not even possible, but what would be the maximum possible x? So this is 40. So I have here between these two, I have 40. And I have here between these two edges, I have 20. So how big can x be? How big can x be? If x is this big, then I don't have a box. It's not a box. If x is this big, then I don't have a box. This cannot be a box. It won't hold anything, right? So what is the maximum, which is even, that is impossible. What is the maximum x value that I could have? So half of 40 is 20, and half of 20 is 10. What is the maximum possible x? Which is really stretching it. 10. I cannot even imagine that it could be 10, but it cannot exceed 10. Draw a graph of the function v and use it to estimate the maximum volume for such a box. In this particular case, we are asked, there is a symbol there of the calculator symbol. So they want us to just graph it with the graphing calculator. So if we go to the graphing calculator and put it in, I will put in the factored form because it's easier for me to put it in. You don't have to. You can put the whole thing in. 40 minus 2x. But it's easier for me to write 20 minus 2x. Then those powers. You close. And I go to the window. Obviously, I'm not going to go beyond 10. And I don't need less than 0, of course. So 0 to 10. With a scale of 2, that would be great. The volume cannot be negative, so I'm going to say 0. I have no idea how high it goes, if you remember that problem we looked at in chapter 2. I'm just going to guess, I don't know, 1,000. I have no idea. With a scale of 100. I'm just going to press enter and see what happens. It's even more than 1,000 for the maximum. says draw a graph of the function, use it to estimate the maximum volume. Way bigger. Okay, not shouldn't say way, but bigger. So I'm going to go back to y equals, and I'm going to change it y maximum to 2,000. With a scale of 200. Or 500, whatever you want to put, 400. Okay, and here's the graph. So between 0 and 10, and it has a maximum, so this is 0 to 10, so 2, 4, 6, 8, 10, somewhere close to 6. It has a maximum. So I'm going to go with second and calc, and I want maximum, which is 4. I'm going to give a left bound of 2 and a right bound of 8. And somewhere here, please give me the maximum. And I expected it to be close to 6. Well, 2, 4, 6, 8. Oh, don't close to 4, I'm sorry. 4.23 approximately. So x is approximately 4.23 centimeters. And the maximum volume will be 1539.60 watt. Very good. Of course. Volume. Very good. Any questions? Now, do you remember the other problem we did? It was very similar, and it was the same idea with the box and the volume. Good. Anything else? Do you have anything else for me? I think I can remove the tent now. Any questions? Chris, anything else?
Number 7 on 3.7.
Number 7 on 3.7. Perfect. Let's take a look. 7 on 3.7. A rational function is given. Complete each table for the function. Describe the behavior of the function near its vertical asymptote based on tables 1 and 2. Determine the horizontal asymptote based on tables 3 and 4. Okay. So all you have to do is just plug in these numbers and then draw a conclusion for all based on the tables.
Yeah, I got like -1 for each one. For the
So you have to plug this function in.
Yeah.
The graphing calculator, and then fill in all these. So let's do that. So go to y equals. So remember, you need parentheses for the top. Although because it's just one term, it's okay. You can get away with no parentheses, but be careful. The denominator needs parentheses x minus 2. And I go to second and table. Yes, this goes back to default all the time now. They set it up like that. So I have to go back and change the independent variable into ask mode all the time, every time. Okay, so I'm plugging in 1.5. I'm plugging in 1.9. Which one did you get? All negatives or something? So as you see, from -3 it jumps to -9, it jumps to -199, it jumps to 1,999. What does this mean?
Horizontal asymptote.
Vertical.
Vertical asymptote.
Vertical asymptote at
2.
2. X equals 2, and it goes on that side. It goes to -infinity. Right? So you have x equals 2 a vertical asymptote, and with numbers approaching from the bigger, right? From 1.5, 1.9, 1.99, with this value smaller than 2, we get -infinity. Is that okay, Chris?
Yeah.
Now for the other one, with numbers larger than 2, with 2.5, with 2.1, and closer to 2.01, and even closer to 2.001. And I conclude that as x gets closer and closer to 2 from larger values of 2, it goes to positive infinity. Now the other two I have, let me go back up. Okay, so 10, I'm increasing. This one will tell me a horizontal asymptote. 10, 50, 100, and 1000. So it appears that the horizontal asymptote is 1. Do we know that? Yes. Is it type 1, type 2, type 3? Oops. Type 1, which means it has a horizontal asymptote, leading coefficient of a leading coefficient. What is the leading coefficient top? What is the leading coefficient bottom? So it's 1 over 1. And you can conclude the same thing by plugging in negative 10 and negative 50 and negative 100 and negative 1000. It has to approach the same thing. But from below, 0.99. Still closer and closer to 1. As x goes to negative infinity, the function values get closer and closer to 1. Very good question. Is this clear?
Yeah.
Okay, very good. Anything else? Do we have anything else? Okay, I'd like to go back. Oh, I didn't mean that. I'm sorry. Yes, that's where I want to go back. Okay, last time, do we have other questions? Anyone? Andrew, any questions? Okay, so last time we looked at some examples, and this was the type 3 function that we know it does not have a horizontal asymptote. It has a slant asymptote, and we also know what? That the difference of degrees, top has to be higher than the bottom by how much? Exactly 1, because the division has to be a line. If the top is degree 4 and the bottom is degree 2, the division will not be degree 1, will not be a line. Agreed? Okay. Then we started chapter 6. We talked about the angle measure. Positive angle, counterclockwise, initial side, terminal side. Negative angle, initial side, terminal side, but clockwise. Standard position means an angle starts on the x-axis and ends somewhere on the circle. We don't care where, but the standard position, the initial side has to be on the x-axis, towards the positive side of the x-axis, and its terminal side anywhere. Co-terminal angles and start and end at the same point. We have angle measures degrees and radians. Now we know that this is 0, 90, 180, 270, and 360. And we define the radian. What is a radian? It's an angle that has an opening equal to the length of the radius. So this angle measures 1 radian. Why? Because it opens on the circle. It's a central angle. And the opening it has on the circle is the same length with the radius. We also know that the circumference is 2 pi r. And if the radius is 1, it can be, then still 2 pi has to equal 360. The circumference in degrees, if you want to talk about degrees, the complete rotation around the circle is 360 degrees, also 2 pi. We divide both sides by 2, and we know from now on that pi, when we say pi, we mean radians, is the same with 180 degrees. Now, if I need 1 radian, I divide both sides by pi. If I need 1 degree, I divide both sides by 180. It is useful to remember that roughly 1 radian represents 57 degrees, a little bit less than 60, 57 degrees. The reference angle is super important. The reference angle is always an acute angle and is always formed between the x-axis and the terminal side of an angle. So here I have alpha. Here I have, this is the reference angle between the x-axis and the terminal side of angle beta. So angle beta has this reference angle. So it's the acute angle made between the terminal side of an angle and the x-axis. So for example, for an angle with a terminal side in the third quadrant, the acute angle, that is the reference angle, is made between the x-axis and the terminal side, which is this piece. For an angle that ends in the fourth quadrant, again, the acute angle, the reference angle, is the acute angle made between the x-axis and the terminal side, is this piece. And you can say, okay, why is this so important? Because we will be able to determine sine of 720 degrees. And you should say, that's not possible. 720 degrees do not fit in a right triangle. You just showed us that sine is the opposite over the hypotenuse, opposite leg over the hypotenuse. What are you talking about? How can 720 degrees fit in a right triangle? It doesn't. But the reference angle will enable us to determine sine of 720 degrees. But if we don't know the reference angle, we will not be able to determine sine of 720 degrees. Okay, by the way, it's 0, but I just gave an example. Okay, then we talked about two formulas. I can determine the length of the arc with this formula. S is the length of the arc, which is the radius times the angle that is the central angle that has the opening, or subtends, we say, subtends that arc. But theta in this formula, if you put it in degrees, you're not going to get anything. It has to be put in radians. Okay, and then we looked at some examples of that. And we also talked about the area of a circular sector. So if I want to determine the area, that's the formula, 1/2 r squared, which is the radius squared, times theta. Of course, theta has to be in radians. So again, r squared will be the radius squared, and theta the angle, the central angle. Then we looked at a couple of examples. And finally, we defined 6 new functions. You can say, don't we have enough? The absolute value, square root, and so on and so forth, linear, polynomial, rational. We talked about so many different radical functions. Do we really need these? Yes. Because without these functions, we will not be able to determine a lot of things. So, in a right triangle, we defined for angle alpha, sine to be opposite over hypotenuse. We defined cosine to be adjacent over hypotenuse. And then we defined tangent to be opposite over adjacent. We defined cotangent to be the reversed, the adjacent over the opposite leg. And then we defined secant as 1 over cosine. If cosine is a over c, secant would be c over a. And we defined cosecant alpha as being 1 over sine. Well, sine is b over c, so then 1 over sine would be c over b. We also established the fact that alpha plus beta must equal 90 degrees. So we wrote all these definitions, and then I asked at the very end, and we ran out of time, this was the last thing we did, give me sine beta. And he gave me a over c, which is correct. And then I said, oh, look at this, a over c. This happens only because alpha and beta, we say, are complementary angles. It means that their sum is 90. What are supplementary angles? Their sum is 180. So this happens that sine of an angle, if they are complementary, sine of the angle, alpha, is cosine of the other one, only because they are complementary angles. Okay, any questions for me? Any questions? So let's go back and practice 6.2. We did not get the chance to do anything else. We just talked. We looked at examples from 6.1, but not from 6.2. We didn't finish 6.2. I just want to look at a few applications. So on page 448, I would like to look at any problem you want between 3 and 18. 3 and 18. If you don't choose, I will. So 3 and 18 on page 448. Yes?
Can we just do 6?
Yes, absolutely. So let's look at problem 6. And I see a right triangle. Here's the right triangle. I am given 8 as one leg, 15 as the other, and I'm told that this angle is denoted by theta. Find the exact values of the 6 trig ratios of the angle theta in this triangle. That's intentional. They twisted it like that and they hung it like, right? But it doesn't matter. We should not bother us. So I write sine theta, cosine theta. That's all I need for now. And you'll see what I will do next to determine the other 4. Bless you. So sine, can anyone give us sine? And you can say not yet, because there is a side that is missing. But I know that this is a right triangle. How can I determine if I have 2 sides? How do I determine the third side in any right triangle? Right. So I'm going to call this x. And can anyone give us the Pythagorean theorems specifically for this? Don't say a squared plus b squared equals c squared. I just want to apply it to what I have.
17.
So,
X equals 17.
so yes, but I still have to write it for everyone to see. 15 squared
Plus 8 squared.
plus 8 squared equals?
Oh, equals. It's reading out.
X squared. So leg squared plus, remembering it as a squared plus b squared equals c squared, it doesn't mean anything. Leg squared plus leg squared must be the longest side squared. This is the way we should remember it. Because I can change the notation and then the formula or the theorem doesn't work. A leg squared plus the other leg squared equals the hypotenuse squared. Ready? Good. So you said that this was 225 and this was 64. So you got that x equals? Yes, but I need, it's x squared. I thought you already gave me. So that's not good enough. I need to find x, which is? Yes. How come that I don't write plus or minus? Because when we take square roots, we know from chapter 2, when I take square roots from both sides, I have to write plus or minus. How come I don't write plus or minus here? It's a distance. It's a distance. It cannot be negative. Perfect. Okay. Can anyone give us, so then x equals 17. So can anyone give us sine theta?
So opposite over.
Yes.
15 over 17.
Good. What do we know about sine and cosine? What is the maximum possible number that sine can be? Exactly. Notice that it's always a shorter leg divided by the longest leg. So it must be a number that has to be less than 1. Okay. What about cosine? Good. You do not have to perform or find the other ones in the same way we did last week. Meaning, you don't have to think in terms of, okay, although it's not wrong, and it's good to practice. Tangent is the opposite over the adjacent. Cotangent is reversed, and so on and so forth. However, I would like to practice now the relationships between these. So forget about the triangle right now. What about tangent theta? What do I know about tangent theta? Forget about the numbers for a moment. Sine theta over cosine theta. That's one definition of tangent. We have not gotten to discuss that. That's why I want to use it. So how do you want to check? You can. So tangent theta is 15 over 8, right? We know that. So sine is 15 over 17. Cosine is 8 over 17. How do I divide two fractions? Right. So I get 15 over 8. 17 goes away. Exactly what we knew, right? Tangent theta is the opposite over the adjacent. Agreed? Good. I know how to find cotangent. What is cotangent? Is 1 over tangent. So let's write it. I don't have to do anything. Just look at this fraction and give me the answer. The multiplicative inverse of this number. That's it. Now I want to find secant theta. Here's the formula. 1 divided by cosine. So if the function starts with s, it's 1 over cosine.
So 17 over 8.
Exactly. And finally, secant, cosecant. Cosecant alpha, theta, is 1 over sine theta. So if the function starts with c, cosecant, it's 1 over s. So I have sine, so this is 17 over 15, and it's done. What is the point I'm making with this exercise? If I have sine and cosine, it takes me a blink to find the other 4. But I have to remember, tangent is sine over cosine, cotangent is 1 over tangent, secant is 1 over cosine, and cosecant is 1 over sine. So bottom line, when I have sine and cosine, the rest will follow. Boom. Okay, any questions? Okay, let's continue. Express x and y. Would you like to choose anything else?
We do 1 through 11 through 16. 14.
Anything you want.
14.
14, very good. So let's look at 14 on page 448. And 14 is a right triangle. There's a 4 here, there's an x here, and it's 30 degrees here. Find the side labeled x and state your answer rounded to 5 decimal places. Very good. So let me emphasize a few things here. One, this is what we don't know. This is what we know, and this is what we know. So I need to think in terms of a trig function that is applied to 30 degrees that will involve these two. Since I don't have this one, I also don't have this, the hypotenuse. So I need a trig function that will involve this leg and this leg. Of course, absolutely. So tangent 30 degrees equals,
Oh, he goes 4 over. Yeah.
indeed, opposite leg over the adjacent leg. And now, remember what we do here. Here's your hint. Cross multiply. This is a proportion. So x times tangent 30 equals 4 times 1. And finally, I want to find x. What should I do to both sides in order to find x? Yes. Be very careful now. The angle is given in degrees. I go back to my calculator. And make sure, click on mode. Make sure that you change the radian into degree if you don't have it in degree already, and press enter. And then get out of there with second and quit. And I have 4. And I divide by tangent is right here, 30 degrees. Close the parenthesis and press enter. So I got, it says, state your answer rounded to 5 decimal places. So x is approximately 6.9282. 6203. It says 6. Oh, 5. I'm sorry. So 6.9282. Very good. Anything else here? Let's work on 18. Good. Let's work on 18 and then go back. I still have to talk to you about this section. It's not done. So in 18 we are given a right triangle with an acute angle theta, of course a 90 degree, x, 4, and y. In this particular case, we're asked to express x and y in terms of trig ratios of theta. So I could have x equals cotangent theta, or I could have y cotangent times sine theta, something like that. I don't know. So let's take a look. So the angle is here. And if I want to express x of using theta, I should not be looking at a trig function that uses both variables. I should involve these two. Yes, I will say tangent theta equals. That's it. Perfect. So now I want to express x. What should I do? It's a proportion. Yes. So x equals how much?
4 times.
That's it. Done. Now let's think in terms of y. I want to find an expression like this for y, but that only has theta in it and nothing else. Not x. So I will involve these two. Sine will be the opposite. Yes, indeed, cosine. Cosine theta equals. Careful. If I make the mistake to write y over 4, then cosine will be more than 1, and that's not possible. So it's 4 divided by y. And then like I did before, I will cross multiply. So y times cosine theta equals 4. And now I have an expression for y that only depends on theta and nothing else. Ready? So how much is y?
So y equals cosine theta. 4 cosine theta. Yeah. 4 divided by cosine theta.
Thank you. Very good. Any questions on this? Is this okay? Perfect. Why? Because I want to get rid of this and it's multiplied. Right? Is it okay? Does it make sense?
Yes, you're getting rid of the...
I'm solving for y.
Yes.
So I have to divide by what multiplies y. And what multiplies y is cosine theta. Is that okay? Good. I'd like to look at number 19 on the same page, 448. I'm given sine theta equals 3 over 5. Sketch a triangle that has acute angle theta and find the other 5 trig ratios of theta. So I will create a right triangle with an acute angle theta, 90 degrees. So what do I know then about those sides? Can anyone say, oh, in that case, so then what is this?
3.
And what is this?
5.
Good. So then I can determine this. How do I determine the other leg? Because I need to determine them because I'm asked to find.
5 squared minus 3 squared.
Yes. So the square root of 5 squared minus 3 squared. So 25 minus 9 is 16. So this will be, yes, 3, 4, and 5 are so-called Pythagorean Pythagorean numbers. Good, very good. So then you're going to give me cosine theta right away.
G, so it's 4, 5.
Good. Then you're going to give me tangent theta right away.
3 over 4.
Good. Then you're going to give me cotangent theta right away.
4 over 3.
Good. Then you're going to give me secant theta right away. If it starts with S, is 1 over this. 1 over C. 5 over 4. So then in cosecant theta, you're going to give me
4 over 3. Oh, 5 over 3.
it's 1 over sine. Any questions on this? Any questions? Okay, I would like to look at problems 30. I'm coming back to 25 to 30 in a minute, but I need to show you something before we do that. But I'd like to look at problems 31 through 43. 31 through 43. Please choose.
38.
38 it is. 38. And we have a right triangle whose hypotenuse is given as 425. We have given an angle up there, which is 3 pi over 8, and the right angle. So when we are told or asked to solve a triangle, it means we're asked to present 3 sides and 3 angles. Since one angle is given in radians, I have to present all angles in radians, and then I have to determine all sides. So I have to list or present, whatever you want to write, it's the same thing, all 3 sides and all 3 angles. Allow me to